Now that we've gotten an up-close and personal view of the aircraft, it's now time to get back to the real matter at hand, the angle of depression. Now, the angle of depression is used by a pilot when he's coming in for a landing. Central, ready for runway clear to take off 0.5 knots. The pilot needs to know when to begin descending in order to make a safe landing at the airport. Now, let's say a plane is cruising at an altitude of about 9,000 meters or 29,700 feet and wants to land at the airport. It must begin its descent so that the angle of depression to the airport is 7 degrees. How many kilometers from the airport must the plane begin descending in order to make a safe landing? We know all we need to know. In order to figure out how far the pilot must begin his descent, we know that the altitude of the airplane is 9,000 meters, which in this case represents the opposite side of the right-angled triangle. We also know that the angle of depression from the airplane to the airport, which is 7 degrees. Now, the two sides of the right-angled triangle that we are concerned with are the opposite side, which is the height, and the adjacent side, which is the horizontal distance from the airplane to the airport. Now, since we do not know the hypotenuse, the most logical ratio to use is the tangent ratio. Remember that the tangent of an angle is equal to the ratio of the opposite side to the adjacent side. So our equation becomes the tangent of 7 degrees, which is equal to the altitude divided by the distance from the airport. And when we change the subject of the equation, we get that the distance from the airport is equal to the altitude divided by the tangent of 7 degrees. The distance is 73,289.9 meters. And we can round this off to approximately 73,290 meters. But the distance must be given in kilometers, while our answer is in meters. So, this conversion is easy. Since we know that 1,000 meters is equal to 1 kilometer, the distance from the airplane to the airport is 73.29 kilometers. Whew. Now that was a lot of calculating. But it shows that mathematics is not just about schoolwork, but it's also useful in the real world to solve real problems, like here in the cockpit of an aircraft. Now before we go, there's one more thing we have to look at. And this is very important, so I'll need your help. I'll ask me to join me. Hey you, hey me, long time no see. Here's what I'm going to do. I'm going to climb onto this ladder here, and I'm going to stay here on the ground. So when I'm looking down, I'm looking at him. And I'm looking up when I look at him. And since my perspective is lower, it puts me at an angle of elevation. Now, the angle formed between my horizontal line of sight and my elevated line of sight is called the angle of elevation. And the angle formed between my horizontal line of sight and my declined line of sight is the angle of depression. I am higher, so my perspective puts me at an angle of depression. So, what is your angle of depression? My angle of depression is 30 degrees. What is your angle of elevation? Well, my angle of elevation is 30 degrees too. See, the angles are the same, just as we are the same. You see, this is an interesting principle of mathematics, and it is always true. Our horizontal lines of sight are parallel, which means that they never cross. Now, the line connecting our horizontal lines of sight is transversal and forms the exact same angle on both horizontal lines of sight. We refer to these angles as alternate angles. These angles are always equal, So the angle of elevation is equal to the angle of depression. And just to recap, the angle of elevation is the angle between the horizontal line of sight and some point above that horizontal line of sight. And the angle of depression is the angle between the horizontal line of sight and some point below that horizontal line of sight. We can use these angles to tell us how tall an object is or how far away an object is. And finally, we now know that the angle of elevation is equal to the angle of depression. Pretty cool, don't it? Remember, mathematics is a universal language. The angles of elevation and depression, take them out to your class and take them home with you. Take them everywhere. They're yours. Bring them to life. Peace.